Hey guys, we're going to do week 11. Let's take a look. Okay, it says select a pair of sides that could be used to prove two triangles are congruent. Okay, so we have an angle, right? And we have a hypotenuse. Okay, so if they tell us this short side and this short side are equal, then that would spell hypotenuse leg, hypotenuse leg. So let's find that one, BC and ED. BC and ED. I need that. Nope. If they gave me that, I don't see it. All right, what else? If they gave me the longer leg and the longer leg, that also would spell HL because the hypotenuses match. So let's look for that one. AC and EF. AC, EF. Okay, so I like this one. So what about EF and BC? So EF, BC. No, not really, because that would mean the medium side is equal to the short side. Notice how that won't work, right? What about BC and DF? BC, DF. Well, no, the short leg is equal to the hypotenuse. No, that's not going to work. What if AC, the medium leg, is equal to DF, the hypotenuse? No. What about what about the hypotenuse equaling the short leg? No. What about AC, the medium leg, equaling DE, the short leg? So I'm only going to pick A. Question number 2, if y is equal to 7.2, so we can add that to our picture, and z is equal to 6, okay? Is there enough information to determine that the two triangles are congruent? So let's take a look. They have an angle that's congruent, right? A right angle. They have a leg that is congruent. And it looks like, yep, they have a hypotenuse that's congruent. So 2 of their legs are equal. So yes, both of their hypotenuses are 7.2. Both of their longer legs are 6. So the hypotenuse leg theorem says that if you have a right triangle, which we do, and the hypotenuses match, and one of the legs matches, then they are congruent. Yes, are congruent. 3, which theorem shows that these triangles are congruent? So I have a side, an angle, and a side. A side, an angle, and a side. That's going to be good, right? SAS. Nice. What do we got here? It looks like they kind of spun this thing around a little bit. Which theorem can be used to show the two triangles are congruent? Okay, so let's see what we got. This is 3, right? Now I'm going to look for this one is 3. That's nice, okay? This one is 5. All right, that's the hypotenuse, the side opposite the right angle. And this one's 5. Okay, so the hypotenuses match and the legs match. So that's going to be hypotenuse leg. Right? Number 5. We're going to have to sketch this separate. So this one, I'm going to sketch off to the side here. All right? And this one, I'm just going to kind of move over here. All right? Now notice, so this is EBD, right? The blue one I moved over, and this one is ABC. And notice that both of them have angle B. They're literally both, that's called reflexive. Angle B is congruent to angle B, that's reflexive. All right, what else? It says, let's say you were given that A and D are equal. So they want to put a necklace here and a necklace here. So copying that over to my separate ones. So right now I have 2 angles that are congruent, right? what could be used to prove that the two triangles are congruent? So they're admitting right now it's not enough evidence. Right now it just spells angle, angle, and that's not a theorem. So they want to say what extra piece of information could be used. So if they give me angle A matches D, they already gave me that. So I still don't have enough. Still not enough. It's a true statement, but that's not going to get me to spell one of the theorems. So let's take a look at BED. So BED and BCA. If you added that, that's angle, angle, angle. And that's not a theorem. Angle, angle, angle is not a isn't a theorem. It is not a congruent triangle theorem. So that's not going to be enough. It would be enough to show that they're similar, but not that they're congruent. Okay, so let's keep looking. It says AEDC. AE, this one, DC, this one. Interesting. I like it, but that's only part of this, if you see that. I think, though, that I could get there. Let me look at the last one, and then I'll go back to that. Okay, so I'm going to put a hold on this one. Let's look at this one. AB is equal to DB. So AB, bam, is equal to DB, bam. Yeah, that spells angle, side, angle, angle, side, angle. So I'm going to pick D. Now, what did I mean by this one might be enough? So using this information, if this is equal to this, would that be enough? Well, notice I have these two angles now are equal, which means this would spell angle, angle, side. Angle, angle, side. Those are equal because they're vertical. And now, because of corresponding parts of congruent triangles, this length and this length would be equal. And I still don't know if I get over here enough to be able to say that this and this would be equal. This maybe tells me this angle would equal this angle, which means that this angle would be the supplement of that angle, and this angle would be the supplement of that same angle. So I can say that these two angles are equal. It's like I'm almost there, but not quite. You see what I'm saying? So definitely going to go with this one. All right, let's look on the back. Question number 6. Prove that ACB, ACB. So this triangle, I'm going to write off to the side. I'm going to write over here. Kind of make it a little bit. So ACB. And prove that it's congruent to this one. BDA. BDA. All right. So what evidence do we have? Well, we have the left side of the blue one and the right side of the red one match. It also looks like we have an arc mark here and here, right? And it looks like both of the angles here, if I kind of erase this a little bit, this whole angle is equal to angle 1 and angle 2. This whole angle is equal to angle 1 and angle 2. So we know that this angle and this angle are equal to each other because they're both equal to angle 1 plus angle 2. Which whatever that is should equal one another. So what do we have there? I've got angle, angle, side, angle, angle, side. So I'm going to pick angle, angle, side. Nice. What about 7? Are these two right triangles congruent? So I have a right angle, right? I have an angle and a side and a side. So this spells angle, angle, side, angle, angle, side. So that is a right triangle theorem. So the answer is yes. Angle, angle, side, triangle congruence. Number 8, JKL. So this triangle, JKL, it's asking, is it congruent to X, Y, Z? Well, right off the bat, I have a problem. Did you notice that X is where the 90-degree angle is? And J is not a 90. So right off the bat, I know it's a big no, and I'm going to explain. In this picture, it does say that the blue one is congruent to the red one. It absolutely says that, but they wrote it out in the wrong order. So let's look at this a little bit deeper. HL says the hypotenuses match, right? And the legs match. So these are definitely gonna match, but I have to have the order down. So notice if I went YXZ, triangle YXZ has to match the same order. So YXZ, I have to go across the side that doesn't have any arc marks to the box and then the 2 tick marks. So I have to go in the same order, across the side with no lines, the box, and then the 2 tick marks. So I need to go in the same order, J, L, K. Notice how this helps us out. We know X is the 90-degree and L is the 90-degree. They're in the same spot. We know YZ, first and last, has 1 line on it. JK, first and last, has 1 line on it. We also know XZ, first and last, has 2 tick marks. And first and last, LK has 2 tick marks. So this is the order you need. This is correct. Nice work. Now for number 9, which is a necessary step to prove that this ABF, this triangle, is congruent to that triangle, EDG. Okay, so I'm going to do like I've been doing, right? I'm just going to draw the red one and the blue one and kind of connect my evidence so they're not laying on top of each other. This is equal to this, okay? This whole hypotenuse is equal to this whole hypotenuse. And it looks like this whole bottom part is equal to this whole bottom part. So that's side, side, side triangle congruence. They should be congruent. Okay. So to prove that, this one is vertical. This is saying this angle is equal to this angle. We already know that, so I don't think I need that to prove. But what I'm a little confused, maybe I don't like this question very much, are these lines trying to say, if this line trying to say this whole side is equal to this whole side, it's kind of confusing. GC is equal to CF. BCD is equal to BCD. I don't need to use this reflexive theorem for this. So I don't need that. I don't need that, I don't think, right? So maybe I need to prove that that this this angle is equal to this angle. Just kind of looking at yeah, I don't like this question. Yeah, I might need this length equal to that length. I might need that. So I'm gonna say C is my best answer. I'm still saying I don't like this question. Okay, for 10, if a proof shows that AF is equal to EG, so let's take a look at what they want. If the proof shows that this whole line is equal to this whole line, that's what I was talking about. And that GC, so it looks like maybe we did need that, GC is equal to CF, right? Is it possible to show that a different triangle, ABF, so ABF, is congruent to EDG? Oh, so I'm going to say yes. Explain. Well, if this little 3 is only talking about the shorter length there, then notice if I can prove that these are equal to each other, then that lets me say that this triangle ABF is congruent to EDG because of side, side, side triangle congruence. Notice every single side is the same length, meaning this length is 1 and this extra little length. This length is 1 and an extra little length, so those have to be the same. This length is length 2, and this length at the bottom is length 3 plus another length. This is length 3 plus another length, so that had to be equal side, side, side. 11, how can I prove that? So let's see what they want. ABE, this triangle, this angle. How can I prove this angle, bam, is equal to this angle, CDE? How can I do that? That's what I want, and how can I do that? Well, notice this is angle evidence. Those are parallel lines. And so if we look at this, do you see the Z? That should remind you of AIAT. That angle, ABE, or where you see the letter B, right, is congruent to CDE, or where you see the letter D, because these are parallel, right? So maybe I have to add a little bit more to the picture for it to look familiar. So I'm just going to extend these parallel lines and extend this transversal. Notice, zip, those are opposite interior angles inside, alternate interior angle theorem. Nice.